Hey everyone, and welcome. Today we're diving into a tool that has absolutely revolutionized software development, Docker. We're going to break down how it takes your code from your local machine and gets it running, well, pretty much anywhere in the cloud. Come on, if you're in tech, you've either said this or you've heard someone say it. It's that classic soul-crushing moment, right? Your code works perfectly on your laptop, but the second it goes to a server, everything just breaks. Well, that one phrase is the perfect place for us to start. So yeah, that whole works on my machine problem, we're going to call that the deployment dilemma. Let's get into why this happens all the time, especially with modern applications. So where does this problem even come from? Well, a lot of it is just sheer complexity. I mean, think about a modern app. You might have one part written in Java, another in Python, maybe something else in Node.js. Each of those pieces needs its own special environment, its own specific server setup to run. Trying to keep all of that consistent when you move from your machine to a test server to the cloud, it's a total nightmare. And this is exactly where Docker comes in and changes everything. The big idea isn't to try and wrangle all that crazy complexity. No, the idea is to standardize it, to put every single piece of your application into its own standard, predictable box. And that standard box has an official name. It's called a Docker image. Now, this is the key. It's a package that contains everything your app needs to run. I'm not just talking about your code. I mean the operating system, the right version of Java or Python, all the libraries, all the configuration. It's all bundled up together in one neat little package. So let's peek inside this box. How's it put together? Well, you can think of it like layers. At the very bottom, you've got a super lightweight operating system, usually some flavor of Linux. Then, layered on top of that is the application runtime your code needs, like Java 17 or Python 3. And then right on the very top, you put your own application code and all its config files. And this layering system is what makes the standardization so powerful. So look here, whether you're building a Java app or a Python app, the structure of the box is exactly the same. They both start with a Linux OS. One gets Java and your .jar file on top. The other gets Python and your Python code. The stuff inside is different, but the package itself is identical. This simple idea of a standard package unlocks Docker's absolute superpower. It's a phrase you're going to hear all the time: build once, run anywhere. So what does that actually mean in practice? This quote from our source material really just nails it. As long as any computer, and I mean any computer, has the Docker software installed, which is called the Docker runtime, it can run your image. It doesn't matter if it's your MacBook, a server in your company's data center, or some virtual machine in AWS or Azure. If it has Docker, it runs. End of story. And this consistency just has this incredible ripple effect. Because every app is in the same kind of box, you can now use the same tools to deploy them, the same tools to get metrics, the same system to check their logs. It standardizes your entire DevOps process. It just takes all that chaos and makes it simple and repeatable. Okay, so let's get practical and talk about the cloud. How do you actually get one of these standard boxes from your computer and into a real-world environment on something like AWS, Azure, or Google Cloud? The workflow is actually beautiful in its simplicity. First, you write a simple text file called a Docker file. Think of it like a recipe, just a list of instructions for building your environment. Then you run a command to build the image from that recipe. Once it's built, you push it up to a central library. And from there, you can deploy it to any server you want. So that central library I mentioned, it's called a container registry. Honestly, the easiest way to think about it is like GitHub, but for your built application images instead of your source code. It's just a place to store and version control all your packages. Docker Hub is a huge public one, but every single cloud provider offers their own private one for you to use. And here we go. This is a super handy cheat sheet for how this looks on the big three cloud providers. As you can see, AWS, Azure, and Google all give you a container registry to store your images. Then, when you want to actually run them, you've got a couple of options. You can use what's called a PaaS, or Platform as a Service, which is usually simpler and manages a lot of the infrastructure for you. Or if you need more control, you can use a CaaS, a Container as a Service, which is designed specifically to run these Docker containers at a massive scale. Each cloud has its own brand name for these, but the concepts are the same everywhere. All right, let's wrap this all up. We've gone through a lot of tech here, but why should you care? What are the big, important takeaways from all of this? If you only remember 3 things, make it these. First, standardization. You get one single, reliable way to package and run any piece of software. Second, portability. That whole "it works on my machine" problem, it's gone forever. Build it once and you know it'll run anywhere. And third, it makes you cloud neutral. Because a Docker image can run anywhere, you're not locked into AWS or Google. You have the freedom to move your applications wherever you want. What this technology really does is lower the barrier for anyone to bring an idea to life. It gives you this incredible superpower, the ability to take any app, no matter how complicated, and shrink it down into a simple, portable box that can run anywhere on the planet. So the only real question left is, what are you going to build with it?